So dual chamber cases right now are extremely popular because they let you showcase your hardware without too much of a penalty on the cooling performance. But like with modern hardware, with big GPU coolers and decent CPU coolers as well, does it really matter? When we compare something traditional like the Frame 4000 from Corsair that has that triple 120mm fan intake at the front, delivering fresh air for our CPU cooler and the GPU, versus something that is completely closed in that regard, versus like the Antec C6 Curve Air, that instead of giving you front intake, you have bottom intake for the GPU, but like how does it affect anything, especially when you're considering going for an air cooler or an AIO. And the obvious disadvantage of cases like this with the front glass is that you don't have that fresh front intake delivery, but many case brands are coming around to including bottom fans with nothing underneath, so the power supply is not interfering with our potential bottom intake, and these are delivering fresh air directly for our GPU. Now, I would argue that you can make a beautiful system still with the traditional front panel front intake with airflow, but you also have to take into account, if you are building with something that has a lot of glass, that your hardware components are all color matched, for example, the cable management is done right, especially because with the C6 now you have that triple view glass, so the booty of the GPU, I keep saying booty, the rear and that whole chunk is visible. That's not... Also imagine your graphics card is not long enough to bypass the motherboard. That would just look awkward in a C6, but who cares what it looks like in the Frame 4000 because the view is from the side anyway. For the cooling components, we decided to go with one of the best AIOs on the market right now, the NZXT Kraken Elite 360 RGB. In our entire AIO roundup, it performed amazingly well for the noise profile that it delivers. I'm not a huge fan of the RGB fans. They just don't look as good as some of the other competing options. As for the air cooler, we have the Thermalright Peerless Assassin 140. Now this thing looks awesome in the white enclosure, but then again, when you start to introduce multiple whites, for example, that's one of the reasons I decided not to use it in a white C6, because there are just too many white variations, both in terms of what is around the motherboard and the case itself. Like the case itself, in terms of the white, is a bit cooler versus all the other hardware is like on the warmer side, and whew, it just does not look good. But how does it impact the temperatures of all these other parameters, including SSD temps and VRMs, for the longevity of your hardware, especially when you take a look into account air versus AIO. Inside a dual chamber concept enclosure for showcase elements without any front intake to begin with, only at the bottom, versus your traditional mid tower with front intake only. And actually looking at all these values over the last 4 days of testing, sure, some things are as expected, but there are a few parameters that really stood out that surprised me and the team. Specifically, if you're air cooling inside the glass box like the C6, there are a few things you can do to make your temperatures way better. Stay tuned for that. Now, for all my testing, I had my acoustic budget at 40 decibels. That's my preferred comfortable place where the PC can still be on my desk. I can have a conversation. It's almost like a hum in the background, kind of similar to what you might expect like an idling AC unit. And that's going to be my noise normalized testing for both the Frame 4000 and the Antec C6, so that we can actually compare apples to apples instead of blasting air and see which one brute forces air better. And inside for the system, I have the Ryzen 9800X 3D and a beefy RTX 5080. So starting with a 360 IO in Blender, which is a very CPU intensive benchmark, in both cases we were achieving very similar clocks on that 9800X 3D. So 5140 to 5150 megahertz on all cores consistently, switching to an air cooler, and all core frequencies drop by about 40 to 50 megahertz, which is not that significant. And here I might say, if you're rendering on day-to-day basis, that gap of 40 megahertz might add up over time, but realistically, it doesn't really matter. Now here's where the voltage data makes everything kind of click together. In gaming, the 9800X 3D with an AIO on both cases locks at a steady 1.231 volts. With an air cooler, obviously that rises, but with the Frame 4000, we go up to 1.246 volts, while with the Antec C6, that goes even higher to 1.259 volts, which is the highest reading in this entire dataset. Now, voltage is possibly even more important than just raw clock speeds, because it is the CPU asking for more electrical current to keep things stable while it is running hotter. And it's the boost algorithm doing exactly what it's supposed to do, but it means the chip is working harder electrically to deliver the same clock speeds, but still drawing more current, more power draw, more heat. So at 1.23 volts on the AIO versus 1.259 volts on the Antec C6 Air, so the clocks are identical and the frame rates are identical too, but one of those scenarios is considerably more comfortable for that chip, especially over long term in day-to-day use. GPUs. Now the C6 stock air configuration produces the most interesting thermal result in this whole test. Under sustained blender load, all 8 cores flat out and hit 90.7 degrees Celsius, and 9800 X3D's thermal limit is 95 degrees Celsius, so our actual thermal headroom is very little. Of course, you can increase the fan speed, but that adds into our acoustic budget that I don't want to break. And imagine you're already in like a warm environment, no AC, that is going to just diminish our performance altogether. So what I did, I added 2 120 mm fans to the top of the C6, one intake just above the CPU cooler in the front, and one exhaust near the rear, without exceeding that 40 decibel acoustic target. And the CPU dropped from almost 91 degrees Celsius to 87.4, so over 3 degrees cooler, and our headroom almost nearly doubled. The CPU clocks, I mean, like there's an 8 megahertz difference, which is not that significant, but a much lower temperature is very welcome. I ran the same 2-fan mod for the Corsair 4000D, which granted no significant improvement, like 1 degree Celsius difference on the CPU, which is nothing, but that means that our fresh delivery on the Frame 4000 is already doing a good job for the air cooling configuration with the Corsair case. Now the GPU, and the RTX 5080 adds an entirely new dimension to testing, especially when we're talking about that 40 decibel acoustic budget. In gaming with an AIO, the C6 keeps the 5080 at 62.3 degrees Celsius, while the Frame 4000 sits at 63.5, slightly warmer, but still close enough to call it a tie. Switch to air cooling and that gap widens. The C6 gives us 62.4 degrees Celsius, while the Frame 4000 climbs to 67.6, and that is over 5 degree difference for the same GPU, same noise level, just a different case. And that makes total sense, because with the C6, we have those 2 fans at the bottom, directly underneath the GPU, intaking cool air without any restriction, without any path flow changes, while in the Frame 4000 we have that beautiful intake for the CPU cooler, horizontal, but then it gets a little bit turbulent once it comes around the GPU area. And the Frame 4000 wins on CPU temps and gaming, about 3.4 degrees cooler than the Antec C6 with an AIO, and 5.5 degrees cooler on air. But here's the thing for the gaming benchmark. In both cases, the CPU is running at identical clocks, the same voltage on the AIO, the same frame rates, so there is no performance advantage with the Frame 4000 when our CPU is slightly cooler, but on the C6, when we have a GPU advantage on the cooler side, we still have everything else the same, but a much cooler running GPU. And here's the interesting part. I totally expected the Frame 4000 to win on every single test because of that traditional front intake delivery, cool air directly for the CPU, for the GPU without any restriction. Also because of the acoustic budget at 40 decibels, I was able to run both the AIO and the case fans on the Frame 4000 slightly higher versus the C6, and it still lost the Blender benchmark in the AIO and when we installed the 2 fans for our C6 2-fan mod. The answer seems to be airflow geometry, right? Like with the C6, we have vertical chimney style effect, bottom intake, top exhaust. With the Frame 4000, we have front intake, airflow gets mixed up on the interior, maybe warmed up by the motherboard and other components, and then gets exhausted by the top AIO. So in CPU intensive tasks, when the GPU is idle, it seems to benefit the chimney style better, but in gaming, we are also now starting to dump all that heat into our area directly, and therefore now the Frame 4000 starts to win a little bit. Now we have 3 more components worth a look: the VRMs, our SSD temps, and of course our RAM. Now the VRMs convert our power supply power into precise voltages the CPU needs, and it sits right around the CPU socket, and it lives off whatever airflow passes the motherboard. And in every single test, there's absolutely nothing to worry about here when it comes to VRM temps, but the pattern matters here. With the Antec C6 with the AIO, it ran the coolest VRM in Blender at 51.6 degrees versus the Frame 4000 53.5, and the C6 2-fan mod produced the lowest reading of this entire test at 48.7 degrees Celsius. That makes total sense. First, we have the air cooler blowing air directly over the VRMs, and we have the top intake in front of the cooler and the top exhaust, so that airflow path is gonna cool down those VRMs for sure. The SSD tells the same story with one detail worth getting right, because modern NVMe SSDs report multiple temperature sensors. Some are for NAND flash and the other is for the controller, which always runs hotter, about 8-9 degrees hotter in every run here. The control temperature matters for throttling, so you want to keep it at below 75 degrees, and we are comfortably well below that on all runs. So the C6 with an AIO runs it at 42 degrees in Blender versus nearly 45 on the Frame 4000, and in gaming both cases hold the controller in the low 50s, so well clear of the 70 plus territory where the drive starts to slow down. So it seems like that vertical cooling effect on the C6 seems to benefit both the VRMs and our SSD. As for our RAM, one component that almost nobody talks about when it comes to temperatures, but maybe for right reason, because in all configuration and all runs, we are running between 36 to 50 degrees Celsius, which is like way below anything concerning. The interesting part with RAM though is that it tracked our GPU temperature more so than the CPU temperature. So in gaming, memory is hotter versus like running the CPU Blender benchmark, maybe because it's not used as much, but also it's right in the path of our GPU exhaust. And so therefore, if you can cool your GPU better, your RAM is going to be cooler too. To my surprise, there's a clear winner here, which is the Antec C6 with an AIO. In Blender, it runs the highest all-core clocks at 5150 MHz, the lowest CPU temperature at 83.1 degrees, and the coolest SSD, VRM, and memory of any AIO configuration tested. In gaming, the C6 with an AIO keeps our 5080 at its coolest, matches the lowest operating voltage in the test at 1.231 volts, and draws the least CPU power of any configuration at just over 88 watts compared to 92 on the 4000D with an AIO and 97 to 99 watts for every air-cooled setup. Now, if AIO is not on the table, going on air cooling and installing two fans at the top of the C6 gives you on-par performance for the CPU as with the Frame 4000 at stock configuration, but we gain the advantage for much better GPU cooling. But at stock, the Frame 4000 is a better air-cooled configuration with just a slightly hotter running GPU. Now, to answer the big question, does your choice of case really matter here? And it's a yes with an asterisk. Not in the my render finished 3 hours quicker or I'm gaining 30% more FPS kind of way, but more like my CPU is running at a few millivolts slightly lower, my GPU is 5 degrees cooler, and my VRM, SSD, and RAM are thanking me in a few years down the line. Simply put, the performance difference at stock settings is not significant. You will not notice it on the day-to-day, but the thermal advantages you gain for the hardware is going to matter over time for sure. And honestly, the most interesting thing here for me is not which case won, but it's adding those two fans at the top for the air-cooled C6 that, you know, made it on par with the Frame 4000 on the CPU temperature side, but while still keeping the massive GPU cooling advantage because of those two fresh intake fans at the bottom. So it looks like it's not a matter of getting a more expensive CPU cooler or a bigger case. It's about just pointing airflow at exactly the right place. And on that note, choose wisely or just add fans in certain configurations. I hope you enjoyed this video. I'm Dmitry. I'll talk to you in the next video.